We'll solve some questions like practice assignment questions. Am I audible, right?
Yes, sir.
Okay, so we'll solve some practice assignment question. Then after that, I will take your doubt. Okay, so first question is design a circuit. Okay, let me. Okay, so design a circuit with the output f and inputs x0, x1, x0, y1, and y0. Let x be can be x1 and x0 be a numbers where the four possible values of x, namely 0, 0, 0, 1, 1, 0, and 1, 1, represent the four numbers 0, 1, 2, 3 respectively. Similarly, yb, y1, y0 represent another numbers with the same four possible values. The output f should be 1 if the number represented by x and y are either both odd or both even. So f should be 1 if the numbers both like evens or odd. Like so, then it will be like it should be like 1. Otherwise, f should be 0. Right. So you have to find the minimized SOP expression for the circuit. Right. So there is a one numbers. So let's write that x1 then x0. There is another numbers. There is a y1 and y0, right? So it will be like y1 then y0, right? And like then say output. So output is up, right? So what says the output f should be 1 if both the numbers are even or odd, right? So either odd or either even, then we can say that this is like output should be 1, right? So let's the write the whole combination. So x1 can be 0, 0, y1, y0 will be maybe 0, 0. Then x1, x0 will be 0, 0, y1, 1, y0 equals 0, 1. It will be 0, 0, maybe 1, 0, 0, 0, 1, 1. Up to that is clear.
Yes, sir.
So this is x and this is y, right? Now x can be 0, 1, y can be 0, 0. It can be 0, 1. It can be 0, 1. It can be 0, 1. It can be 1, 0, 0, 1, 1, 1. Up to that is clear.
Yes.
And now x can be 1, 0. It can be 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1. Right? Up to that is clear. Now x can be 1, 1. It can be 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. Okay. Now question is saying f should be 1 if the number represented by x and y are either both odd or even. So if both odd or even, then f should be 1, right? Now you can see that first row, this is a even number 0, 0, and this is also even number, right? Hello.
Yes, sir.
So it will be 1, right?
Hmm.
Now second row, you can see that this is even number, but this is odd, so it will be
Right.
0.
It will be 0 in that case, yeah.
Yeah, and third one, you can see that this is a even,
That is also even, yeah.
that is also even. This will
So
be
we just check the LSB, sir, right? The least significant bit or whatever the last bit is. If it is 0, it is even then in that case.
correct, correct. That yeah. And here is this is a even, but this is a odd, right? So this will be 0. And here it's like this is a odd, but this is a even, so this will be 0. This is odd and this is also odd, so this will be 1. This is odd, but this is even, this will be 0. This is odd, this is also odd, so this will be 1. So kind of you have to fill all the like 1, 0, 0, 0. This is also like even, both are even, so this is odd, this is like this will be 1. This is even, this is odd, this will be 0. This is even, but also this is even, so this will be 1. This is even, but this is odd, so it will be 0, 1, 1, and 0, 0. This is odd, this is even, 0, 1, 1, 0, 1. This will be odd, and this will be odd, 0. So kind of you have to,
One, one. No, no, one, sir.
yeah, this will be 1.
What
Sorry,
a one.
yeah, then it will be 0, and this, yeah, thanks. Might be I forget. So now you have to find the SOP, right? So how to find the SOP? You have to take the one part, right? So now
Hmm.
let's write the SOP expression. So let's write in the black color. So y equal to, now we can see that you have to take this. So this will be x1 bar, x0 bar, y1 bar, y0 bar, like. Then you have to find, they have to take this. So this will be,
So you
uh,
have to add all of the ones up and then simplify, yeah?
yeah, yeah, correct. You're right.
That's a huge, huge lengthy process then.
Yeah, the, that's why you are taking like in the practice assignment. You can like solve, you can like, it's lengthy process, but if you solve this
Mhm.
question, you able to learn all the things.
Okay.
So
I mean, there's no problem solving. It's just a bit time consuming. Like, one question in that regard, from the options, is there a way to figure it out?
uh, from the option, yeah, I
Like
can
trial
figure
and
out.
error or something?
uh, See, the thing is like, if you see the uh, like carefully,
Hmm.
so you can see that, so when like, what we can say that uh, x0, you can see that this part,
Hmm.
x0
Exactly.
and y0, right? So when like both are 1,
Hmm. Then it is, then the
it,
output is one.
and both are even,
Hmm.
both are 0, then it will be, output will be 1. So there will be two cases, both are 1, x0 and y0.
Technically, x0 equal to y0 is the ultimate condition. Now we'll have to check that, right?
Yeah, so if that is 1, or both are 0, then it will be give the output.
Hmm. Hmm. True.
So final expression will be that. So if you simplify all the things, final expression will be getting that. Or you can just logically, you can also think when will get the 1, right?
Hmm. X0 y0 plus x0 bar dot y0 bar, I think that
Yeah,
is
oh sorry, y0 bar, yeah, correct,
y0
thanks.
bar. So either 1 and 1. Okay, means if they are different, it is definitely going to 0. Okay, so either if both of them are 0 or both of them are 1, at least one of the two expressions will be 1. Okay.
Yeah, correct.
Yes, yes, yes. So then second option, I believe, right?
Yeah, yeah, yes. So second option will be. So if you think logically, like, so the simple like simple method is just draw the truth table and simplify.
Hmm.
If you simplify, then you will get the same. Then
Hmm.
if you want to think logically, then you can also like write that equations.
Logically, it will save a lot of time, I guess. I mean, but
Ha,
then we'll have to understand what is actually happening. Like,
ha, correct, correct.
what is giving 1, what is giving 0.
Yes, yes, correct.
Excuse me, sir.
Yes.
So is it like a not of a XOR gate? So it's like a,
Yeah, it's XNOR gate.
yeah, it's an XNOR gate. Yeah,
Yeah,
that's
yeah.
what. Mm.
So after that is clear for everyone.
I think this is a part of graded assignment as well. I think one question.
Okay, we'll take. Hi, good evening,
What,
Big
what?
Boss.
Good evening. How are you?
Good, I'm good. You,
What is a XOR gate?
JOR gate means like,
Different
JOR.
outputs give 1, same output gives 0. And that is all.
Okay, I'll simply give the truth table.
Hmm.
That will be good.
Exclusive OR, right? That
Yeah.
Exclusive
means.
or.
So suppose there is a X. I think this is a symbol of JOR. So this is X and this is Y.
Hmm.
And if you find the X JOR Y, so 0 1 and 1 0 1 1. So If like odd numbers of 1 is there, then output will be 1. So you can see that here is a odd numbers of 1 is there, right?
Hmm.
So it will be 1, and here also it will be odd numbers of
Hmm.
1 is there, so it will be 1. Otherwise it will be 0. So this is the JOR gate.
How about X, Y, Z, three variables?
Okay, so X.
In that case, Vimlesi, like, see, XOR gate is what? Exclusive OR. It means only one of them can be 1, only then output is 1.
Okay, so 1, 2, 3,
So
4.
only
1, 2,
3,
3,
1, 2,
4.
3. 3 will give.
0, 0, 1, 1, 0, 0, 1, 1,
1.
0, 1. So in that case, if you can see that this is a, you can see that here is a odd numbers of 1 is there. There will be one. So here it will be 1. Here also odd numbers of 1 is there. It will be 1. Here also odd numbers of 1 is there. And here else odd numbers of 1 is there. So this will be 1. Otherwise this will be 0, 0. Here you can see even numbers of 1. So 0, 0. So
Okay,
this.
so I mean, this is how to create the truth table and then find out the ones and zeros.
Yes. So it will be like so if you find the expression, so f will be x bar y plus y bar x. If you find this truth table, so it will become x bar y, y bar x.
Y over X, yeah.
I mean, and between these, and if it is so, number of variables are say suppose k variables,
Huh.
then how it will be?
So if it is suppose k variable, suppose n numbers of variables, so it will be like as x jor y jor z dot 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 dot. So you have to like again jor with suppose another variable is z, so z kind of that. So it will be like you have to
Okay, now
x.
apply the formula,
Correct.
the Morgan formula.
Yeah, x bar y z. It will be like
XY bar Z
plus y bar x
Z
z
plus Z bar XY.
z bar
XY.
uh, z bar. Wait 1 minute. So x y bar z plus y x z z bar, and there will be like plus z plus x bar y plus y bar x kind of that. So just simplify the formula. That will be good, right? Now question 1 is clear for everyone.
Yes, sir.
Okay. Now the second question, right?
No, this table I understood, but what is the minimum SOPA? How to find that?
Minimum, so we have to minimize the whatever you got now. You have to minimize all the things. Okay, so let me share the, I think solution is there, I think. Okay, so yeah, you can see that you got the truth table, right? My screen is visible, right?
Yes,
Yes,
yes.
sir.
So you got the truth table. Now you have to minimize the expression.
Wherever f is y, one,
Huh.
so taking those terms and
Yes.
then minimize basis. Okay,
Yeah,
understood.
yeah, minimize. Okay, now question is, what is the minimum numbers of two input NAND gates required to create the circuits, the minimized expression in the above equation? So you have to find the minimum numbers of two input NAND gates. Okay, so let me like give brief expression about the NAND gates, right? So
Sir, is this the practice assignment we are doing right now?
yes, like practice is seven we are doing.
Achha.
So because we are solving, because you can solve the graded assignment easily, like if you solve the practice assignment and in
Yeah,
the
this is important. This is required.
and the quizzes also, like this kind of question will be come, so it will be helpful for you also.
Yes, sir. Yes, sir.
Okay, so AND gate.
Two input NAND required to create a circuit for minimizing.
Yes, so AND gate is kind of like that. Suppose this is x and this is y, so this is a kind of and then not. So what will be the truth table? XY. Suppose this is a X dot
1,
Y
0.
and this is a X dot Y. This is a NAND gate, right? So
Hmm.
suppose this is 0 0 0 1 1 0 1 1. So 0 0 will be 0. It will be 0 0 and this will be 1, but not of end. So it will be 1
1 1
1
1 0.
1 0, right? Now this is a NAND gate, right? Sorry. And NAND gate is a universal gate also, right? So how NAND gate is a universal gate? NAND and NOR also.
Hmm.
So because from NAND gate we can derive
All
NOT gate,
expressions.
OR gate,
Hmm.
and AND gate also, right? So we'll see one by one. Right? So how to derive a NOT gate?
So for a universal gate, these three gates if we are able to derive these three gates, not or and, then
Yeah,
that is universal gate.
yeah, correct. So
So
NOR
why
gate,
so?
because these are the basic gates, right? So if you are deriving all the three gates, right? So you can derive all the gates then. Because if
Ah,
you see any circuit with the help of OR gate, NOT gate, and AND gate.
yes.
So and NOR gate also a universal gate, right? So now we'll see how to NOT gate from NAND gates, right? So this is a NAND gates.
Hmm.
X y, it will be X dot Y bar. So if you like short circuit two inputs, then you will get the NOT gates. So if you suppose this is X, this is Y, if you short circuit two input, if you give, then it will be X dot X bar. So X dot X equal to X, so it will be X bar. So with the help of short circuit two inputs, we can get the NOT gate. NOT gate is clear for everyone.
Oh, 1 minute, sir. 1 1 if I give, 1 if I give, it will be 0 0. 0. Okay, yes, sir.
Yes, got it.
Mhm.
Now we'll derive AND gate from NAND gates, right? So we'll derive AND gates from NAND gate. Right. So how to derive? So you can see that X Y, right? So this is a, we know that X bar bar we are getting X, right? So this is X dot Y. If you to want not get here, so means like if you short circuit two elements, we'll get X dot Y bar bar. So we'll get the X dot Y. So this is the AND gate from NAND gate. This is clear for everyone.
X
Yes, sir.
bar, X bar, NAND X bar. Yeah, yes, sir.
I hope that is clear.
Hmm.
Okay. So if you have any doubt, you can ask. We can like Rahul, Bimles, Afnan, Sanjay Kumar. Okay, then we'll derive that OR gate from NAND gates, right?
Or, yeah.
So sorry. So how to derive OR gate from NAND gate? So we can see that. So suppose X bar and dot Y bar. If you get whole bar, what
Hmm.
are you getting?
X plus Y.
You're getting X bar bar plus Y bar equal to X plus Y. Correct?
Yep.
So first you have to design first X bar then y bar. So first we are designing x bar and y bar. So we will get x from x bar. We'll get and it will be get y bar.
Hmm. And then
Then you
NAND
have to
at same.
NAND, right? So you'll be getting NAND. So we'll getting x plus y. Up to that is clear for everyone.
Yep.
Okay. Okay. Now JOR gate using NAND gate, right? So we have to design the JOR gate. Using NAND gates. Okay, so how to design JOR gate using NAND gates? Okay, so what is the syntax for JOR gate?
XY bar plus YX bar.
X bar y plus y bar x. So you have to design x bar
Hmm.
y plus y bar x, right? So what we have to give here? So let's design, then we'll simplify one by one, right? So
First, make the knots.
yeah. Okay, so here we'll get x. Okay, so from here what we'll get? This position x dot y bar, correct?
Hmm.
Here we'll get
Where
in this position what we'll get?
x dot y bar
X dot y bar
plus x, I think.
plus dot, it will be like we are doing n, right? Dot x whole bar.
Whole bar, yeah.
Here we'll get x dot y
Bar dot y whole bar.
whole bar.
Hmm.
And finally what we'll get?
NAND multiplication.
X dot y
Dot kara.
dot x whole bar, then it will multiply x dot y whole bar
Hmm.
whole bar, right?
Hmm.
Now let's simplify.
Remove the bar, make it plus.
Yeah, correct. So remove the bar, you have to make it plus. So
And
you'll
then
get x dot y
bar.
bar dot x, we'll get bar right? Plus we'll get x dot y bar bar. So bar will be cancelled, right?
Hmm.
Then we'll get x dot y bar dot x
Bar.
plus x dot y bar dot y, correct? Right?
Yeah.
Now you can take, see that x dot y bar we can take common, right? X dot y common, it will be x plus y.
Hmm.
It will be okay. So okay, let's okay, let's divide, like what will get? X bar plus y bar x plus
X bar
x
dot
plus y bar y, right?
Hmm.
Here what will, this will cancel, x bar dot x, it will be cancelled, right?
X
X bar
bar
dot,
y bar will be gone.
yeah, so it will be, this will be cancelled. So
How did we simplify this? X bar dot y bar, x bar
now
plus y bar, x.
because x dot y, we know that De Morgan's law, x bar plus y bar, correct? This is the De Morgan's law. So you can see that this
But
is
this
the,
is on the whole expression, no?
no
Here,
no,
I mean, part-wise
this is
expression we have.
x dot y bar, this is the expression x dot y bar dot x, right, plus x dot y bar dot y. So we can simplify this expression, right? Hello.
Yes, sir.
So it will be
Okay.
x bar plus y bar, it will be x
Hmm.
plus x bar plus y bar This will be y. Now you can simplify. We know that x bar dot x will be 0, right? So x bar dot x will be 0. We'll get y bar plus y bar dot x plus, we
Plus
can say
y
that
x bar.
x bar y, y bar y will be
Mhm.
cancelled. So we'll get the, so how many numbers of get requires? It will be
4.
1, 2, 3, 4. If you design x nor get, so again one and get is required, right?
X.
Can we repeat this XOR gate using NAND gate, and
Okay.
how we arrived at this diagram?
Okay. So see, so we have to finally like final expression is x bar y plus y bar x, right? Correct. Hello. So am I audible, right?
Yeah, yes, sir.
Okay. Now
So
like
we're making one not of x, one NAND, not of y, one NAND,
yeah,
and then
No, so we have this XOR gate is like x bar y plus y bar x, correct?
yeah, correct.
From
So
there, how do we go about designing the diagram?
yeah, correct. So if you see that, you have to design x bar y and y bar x, right? So
Yes.
if you simplify that, so let's go to the reverse, then we can it will be good.
Hmm.
So x bar y plus y bar x, so you can write that x bar y dot y bar x bar bar whole bar. I think this is correct, right?
Yep.
You can write here. You can
Yes.
write,
Yes.
right. So now we have to design these things, right? So you can see, you have design, you have to get here like x bar y, and here you have to get y bar x, like this is bar and this is bar. Then after that we will get this, right? Up to that is clear. In one input we get x bar y, and another input y bar dot x bar. If we get bar, then we'll get the y. Now how
Okay.
to get x bar y?
Stepwise, we are doing the diagram.
Yeah. Then how to get x bar y? So x bar dot y, how we are getting? So you have to just reverse all the things. Just work out this example, you will get to know how to.
Sure.
Otherwise, this is like kind of standard. You can remember this diagram also.
Okay.
Kind
I'll
of we
try.
are getting reverse.
Yes. Yes.
Okay. Now for design like XNOR get, from NAND get.
Excuse me, sir, one question may I ask, please, before we go forward?
Yes.
So short circuit, could you please explain me once again? I mean, like, I understand it was explained earlier, but I want to.
Okay. Okay. Suppose so okay. So this is a NAND get, right?
Hmm.
This is a X and this is a Y.
Yeah, there are two inputs. Yeah.
So what will get? This is X dot Y bar, right?
Yeah.
Suppose we want to implement non get. So what we can do? Suppose we like join the two wires.
Okay.
Just join the
Then in
two
that
wires.
case, the both the inputs are same, right?
Yeah.
X is equal to y. That is
Nah. So it will be, we can input only one input, right? Not two input, right?
right. Right. Basically, it's
So,
one input. Yeah.
so suppose we are giving X input. So what will do? X dot X bar. So X dot X is X. So it will be
Hmm.
X bar. Correct?
No, so we can take y also, right? I mean,
Ah,
what we call it doesn't matter then because it's after all one input only, right?
yeah. After got one input and it will be inverse.
Okay. Okay. I understand. All right.
Yeah.
Thank you, sir.
Yeah. Now for XNOR get, how to so simply like you have to
So if
use.
we short circuit, then even if we are giving two different inputs, that doesn't matter.
So it will get like only one input, right? Because you have to design, ultimate design is not get, right? So uh, how you can give two inputs? Because we can give only one input, na? Because there is a only
No,
one
what
input.
we did in the diagram, we created a transverse line connecting the two inputs.
Okay. So diagram is like yeah. So you can give only one input, right? So if you join like kind of that.
Then what is the meaning of this kind of diagram? It's simply a not gate, no?
Yeah. So we are designing a not get from NAND get. So basically, how to design a NOT get from NAND get, because we are calling NAND get is a universal gate, right? So if it is universal gate, then you have to design all the basic 3 gates. So I explained like how you can design NOT get from NAND gate.
No, but then it was a two input NAND gate, no?
Yeah, two input
From
NAND. Yeah, two input NAND gate. So suppose there is 2 wire, right? Okay, here you can give two. There is a 2 wires. One is wire, another wire is. Suppose you want to design NOT gate. NOT gate means what do you mean NOT gate? So if you put 1, it will give 0. If you 0, then it will be 1, right?
correct.
So if we short circuited, you can give only one input, right?
Okay.
So whatever you give input, suppose you are giving 1, what is the here it will be given. So
Okay.
both are
So if we short circuit, then it is no longer a two input NAND gate. It
yeah, it
becomes
will be
a single input and
yeah,
not gate.
yeah, correct. So it will be 1.1 bar. So it will be 0. So we are achieving ultimate goal, right?
Yes.
That's why.
So even if it is 0, it is going through the AND process because
Yeah,
AND is still there. So
yeah,
we do 0.0 and after that we get 0 and then we do the NAND. Not.
yeah,
Yeah.
correct, correct. So
Okay.
you have to ultimate goal is we have to design the not get, not like
Right, sir. Right.
yeah, right. So uh, so XNOR get from NAND get. So just you have to use another NOR get, another AND get. So you'll get the. So if you saw the output for 2 inputs, what is the uh, XNOR get? XNOR get will be
Nor in front of nor only one more NAND should be
yeah. So it will be like XNOR. It will be completely opposite to. So it will be 1 0 0
one.
1. So it will be x bar y plus xy, I think, right? So we'll need one more NAND gate, right? So
Hmm.
here in these questions, what is the minimum numbers of 2 input NAND gate required to create the circuit for a minimum expression? You can see that this is the NOR gate expression, right? This is the NOR gate expression. So you require 5 NAND gates. I hope you get it, right? Able to get it. Bimles, Kostav, Rahul, Sanjay Kumar, Afnan, any doubt?
I'll have to revisit.
Yeah, yes.
Yeah. One thing, sir. See, there are only 3-4 gates, right?
Huh.
We can create all gates with NAND and NOR because they are universal ones.
Yes, yeah, correct,
If we
correct.
try to figure all these gates out on our own, that is the maximum limit from which the questions will come, right? Okay, how many gates are required using NAND
Yeah, like what is
create
the
NOR?
minimum numbers of gets required?
So if we just know the numbers, then that's it. That's all we
No,
have
no.
to do. There will be
Sometime
nothing.
what happen? You will give the
Expression.
expression like a new expression and lacks the what is the minimum numbers of NAND gates. So I think GA and practice is given. GA, if you solve the GA, there is a one timing diagram and we ask what is the minimum numbers of NAND gate and NOR gate. So it will be like if you know the basic, you can do that.
Okay. Okay.
Uh,
I'll have
yes.
to do that.
Okay. Okay. Now question number.
If I max terms 3.
Yeah. Question number 3. List the max term ever for the Boolean expression whose truth table is given below. So you have to basically find the POS, right? So
Hmm.
for POS, we'll taking the 0 part, right? So you can see that you have to take this 0. Sorry.
A bar, B bar, C will be there. A bar,
So
B bar, C bar.
so it will be for POS. We are taking if 0 is there, then we are getting only A. Then sorry.
So the zeros will be reversed as well, right?
Correct.
Then
So
A,
it
B,
will
C.
be like A plus B plus C for this,
Then
and for this we'll get
A, B bar, C.
A plus B bar C, and for this we are getting
A bar, B, C.
A bar
B plus C.
B plus C, and for this getting A bar
Bar
plus.
B bar C.
So we have to multiply, right?
Multiply.
So it will be like A plus
Okay.
B plus C. It will be A plus B bar C.
A bar B C. A bar.
C plus B plus C. Then it will be A bar plus B bar C. So I think which option is correct? You can just, I think option 1 is correct. Right?
No, sir. Option 1, A bar B bar C bar, all three there. That is not in there, right?
Okay, then maybe.
I think last one. I'm not sure.
Okay, I think we have to change the option. I think it's not A plus B plus C is not there, right?
A plus B plus C is not there.
Okay, then we'll change the option. It might be printing mistake.
Okay.
Okay, so this will be the correct answer.
Hmm.
Okay.
This is where I had a confusion over here because options were not.
Oh yeah, maybe like a printing mistake is there. We'll update the answer. Don't worry.
Yeah.
Okay. Right. So okay, now consider the circuit shown below. Right. So consider the circuit shown below. Given that the inputs are supplied uniformly randomly, what is the probability of the output being at logic 0? Right. So you have to find the what is the probability of the output being at logic 0, right? So first you have to
make the entire truth table of the whole circuit, right?
not make the entire truth table. You have to just solve Boolean expression. That's it. Okay,
Can you please explain the problem statement first?
Oh, okay. So consider the circuit shown below. So this circuit is given below, right? Now we are asking what is the probability of the output being at logic 0. So what's the probability? Like you can see that x, y, z, zw, there are 4 variables. So 4 variables means there are 16 possible input will be there, right?
Yes.
So out of 16s, what are the like so there are x, y, z, and w. So there are 16 possible will be there. So out
Yes,
of 16,
the first question with the truth table we drew, that was 16 only.
yeah. So out of 16, like how many inputs are 0? So this will be the app. So out of 16, so there will be 0, 0, 0, 0. So this, so out of 16, when like output is 0. If it is like
I mean, in the truth table for all these 16 rows, wherever f is 0,
yeah,
that we have to find out.
yeah, that you have to count. Then you have to just suppose there are 8 inputs are giving 0. Then what will be the probability? 8 by 16 into 100.
0.5, yeah.
Sorry, 8 by 16, I think. Sorry, yeah, not 100. So it will be 0.5, right? Correct?
Okay.
Yes.
Okay, so this types of problem, how to solve, right? So if you draw the truth table, it will be like lots of component will be there, right? So it will be like lots of calculation will be there. So how to solve that types of problem?
Minimizing the expressions.
Yeah, minimize the expression, that will be the good. So you can see that
X or
what will get from this will get x bar y. Okay, now what will get this will this will get
y dash z dash.
w bar z.
Yes.
W bar z.
Sorry,
Right?
w bar z. Yes.
Yeah. Now here you will get w bar z plus z bar. Right? Here you will get x bar wz. Here you will get
X
bar wz plus z, or sorry, x.
X bar wz plus x.
Yeah. Here you will getting y x plus x bar wz. Correct. Here you will getting x bar y w bar sorry.
Z bar plus w bar z. Yeah.
Yeah. So I'm sorry. Here getting x bar y w bar z plus z bar. Correct.
W bar z plus z bar. Yes.
Now this is app. Sorry, someone's phone is ringing. 1 minute.
X dash W Z.
Now what will be f?
The plus of those two.
So it will be, so I'm writing here, x bar y w bar z plus z bar plus y of
X plus
x plus x bar
WZ.
wz, right?
Hmm.
Now why will get here, what will get? That if you multiply x, so we'll get y x bar w bar z plus x bar z bar will get, correct?
Yes, sir.
Yes, and you will get y x plus x bar w. Now if you are taking y as a common, right, so we'll get y as a common, then we'll get x bar w bar z plus x bar z bar plus x bar wz, correct? Now y, now we can take x bar z, and x bar z is common, so x bar z, so it will be w plus w bar. So if you are taking this is a common, right? Okay, now it will be plus x bar z bar plus x. Now it will be y x bar z bar plus x bar z bar plus x, right? Now here you can take x bar as a common, right? X bar, it will be z plus, we are taking common between that, z plus z bar plus x, will get x bar plus x, and we don't know that
Y
x,
only.
it's y only, right? Now we can think that, like, from how many inputs y will be 1. If y will be,
0.5.
yeah, y will be 1, then output is 0. Then you can see that y will be 8 times 1, right?
8 times y will be 1, yeah.
So it will be 8 by 16, so it will be 0.5. I hope
And
you got it.
if the final expression contained two variables,
Then you have to check the, like, if some expression is there, suppose x dot y. So how many times x dot y will be?
0.
Yeah, x dot y will be 0.
but in that
Like,
case, I mean, okay, in few cases it might be easier to simplify, but ultimately you will have to go back to truth table. It seems.
yes. So, like, truth table, I would say go to Boolean expression. In the exam also, like, some simple things will be there, so you'll able to find it.
Excuse me, sir. May I ask a question, please?
Yes.
So this 8 out of 16, that fraction that is coming up, right? So 16 is coming from the total possibilities that we had. So it is like 2 power 4 and it gives us 16. So that we understand.
Mhm.
Now you're saying that y will be exactly half of the times it will be 1 and 0 or whatsoever. So why is that? It could
Okay.
also be like 9 by 16 or anything else. Why are we considering it is only 8 times?
Okay, so
For 3-bit inputs,
okay,
in
so
the
suppose this is a 4-bit input, so x, y, z, w, right?
No, I mean there might be internal dependencies also, no? Therefore, in that case,
Okay. So first will be 0, right? All that will be 0.
yes, sir.
Then it will be 1, right? So it will be 0,
Right.
0, 0, 1.
Mm-hmm.
Then it will be 3, right? 0,
Right.
0,
1 0.
2. So then it will be 3, right? 0, 0,
Yeah. 1 1.
0, 0, 1, 1, right?
Yeah.
Now it will be 4, I think, right?
Yeah.
0, 4.
Zero,
And it will
yeah.
be 5, right? So
5
what will
0 1 0 1
0, 1, 0, 1.
0 1.
Then
Yeah.
it will be 6, right? So
Yeah.
what will be
0
6?
1 1 0, I believe.
0, 1, 1, 0. Then it will be 7.
Yes.
0,
1 1
1,
1.
1, 1. Then it will be 8. So it
Yeah.
will be 1, 0, 0, 0. Then it will be 9. So 9.
We continue like that again. So
Yeah. So 9 will be 1,
1001.
yeah.
0, 0, 1. Then it will be 10, right? So 1, 0, 1, 0. Then it
Yeah.
will be 11,
1
right?
0 1 1. Yeah.
0, 1, 1. Then it will be
1 1.
0 0.
0
0,
0.
yeah.
Then
1
12 bit.
1 0 1
1 1
0 1,
0 1.
and lastly we have 1 1 0 1 1 1 0, and then lastly we have 1 1 1 1.
Okay.
Yeah.
So if you count y, how many times comes? You can see that
8
1,
times.
2, 3,
Yeah.
4, 5, 6, 7, 8. So it will be exactly 5 times.
No, no, it is
8
irrespective of
times.
the other
If it
uh
is if it is 4 variable, then it will be 8 times. If it is like 3 variable,
hmm.
then how many times will become?
4.
Yeah, 4.
So for each number of for each like 1 unit increment in the number of variables we have, right? It'll be doubled, I think, right?
Yes. So
Is
for if it is that 2 variable, then while 2 times. If it is 3 variables, so 4 times. If it is 4 variables, it will be 8
yeah.
times.
Okay, okay, okay. I understand. So, okay. So because it was 16, we just gave it like
Yeah, correct.
8. Because of the fact that yeah, it was 3. So okay, they are both related then in that case. So wouldn't it be always 50% then, sir?
It will be always 50%.
Sir, here it's only one variable y. So even if we put 0 and 1, and then probability of 0 is 1.5, probability of 1 is 1.5, 0.5, and both have 0.5 probability, so it will be 0.5.
Yeah, correct.
So yeah, so in if the expression is different, let's say y plus x or y dot x, then we take
No.
we put the truth table for two variables only,
Yeah,
y
correct.
and x, and then find the how many times it will be 0 and how many times it will be 1.
Yeah, correct, correct.
So okay, one more question, sir, in that regard. Then in that case, so final expression that we are getting. So in this case, it was just y,
Yes.
right? So let's say there is something else. So for that, whatever final result I got, for that I'll draw the truth table.
Yeah,
And
then
then,
you will get how many times you are getting
yeah, yeah, how many
one.
times I'm getting, and then that will be the total, the denominator I believe will remain the same. That is from the original
Yeah, correct.
truth table, right?
Yeah, total will be the same.
Okay, okay, yeah,
Huh,
that is all. Thank you, sir.
correct. Okay, then.
If
Basically
you have to
creating
keep
a
the denominator same, then you should take all the okay within that this 16 possibility. You should choose all the possibilities,
Yeah,
Right.
right?
because
So let's say now there are two variables. So if you want to take the denominator as 16, then you should consider all the 16 possibilities
so if it is two variable,
within
then
the 16 variables. Yeah, within
it,
the 4 variables.
so if it is two variable, only two variable, then it will be like total numbers of possible will be 2 to the power 2, right?
no, he's saying in the final expression, minimized expression,
Oh,
not
minimize expression. Then total will be, denominator will be 16. Okay. Sanjay Kumar,
yeah,
like,
basically yeah. So for these four variables, there will be total 16 rows, and whatever final expression we are getting after the minimization, create a new column and find out the number of ones, count them, and then
huh,
take the ratio.
But
Right,
but
right.
for this expression y, we don't have to take 8 by
Correct.
16.
That is
It
a
is just 0 1.
simple thing.
So it's a
Correct.
1 by 2. It will be the probability.
yeah, correct.
So even if there are, let's say, two variables x and y, so just put these two variables and then check how many times f is 0. So it will be, let's say, for two variables it will be for or it will be 1 by 4,
Suppose the
and for
final,
and it will be 3 by 4.
hypothetically, let us say the final minimized expression is like y dot x bar and plus w.
Why
Just
the X?
Then you should take three variables in that case.
Yeah, correct.
So
yeah.
it will
No,
be
after this step, how we should go?
see, you put all these variables in truth table and then find out. But your denominator will be 2 power 3 this time,
Huh.
not 2 power say 4, because it's you have reduced the variables, right? So you should
Okay, so
also
No, even if you have
basically
reduced the
you are saying
variables,
taking a subset and within
yeah.
working
So
within that
you are
subset.
only taking the subset, right? Y dot x bar into plus w. So in that case, you should only choose the table which corresponds to these three variables. So in that case, your answer will be the same.
Okay,
I don't think so, because like, see, your input
no,
was
we
a
can
four
try and
in.
then find out.
Yeah, whatever Sanjay said, like it's like kind of correct. Like both way are fine. Like if you can do like, suppose okay, let's
Sir, Shubhendu sir, the
yes,
question is that see, we have four inputs in this circuit, right?
yes, yes.
So
So
number
it's
of
like
possibilities
kind of
is 16, right?
yeah,
Now, if the simplified expression has three variables,
Yes.
Despite that, my denominator is going to stay constant at 16, right? It won't get reduced to 8 just because I have
Ha,
3 variables, isn't
correct, correct. So suppose let's take like very minimal like example. Suppose suppose we are taking x, y, z, right? 3 variable.
Hmm.
Okay, so when it will be like suppose we are taking only that so when it will be 1 and both are 1, right?
In 2
All are
cases.
one.
All are 1, huh?
So we are suppose we are taking all are 1s. Okay.
Hmm.
Suppose if you draw the truth table, so what is that? You draw
XYZ equal to 1 will be in 2 cases.
in 2 cases, right?
When W is 0, W is 1, 2 cases.
When w is 0, so if you find 2 by 16, right?
2 by
It
16.
will be 1 by 8. If you are taking like minimize expression 3 variable, so x, y, z, we are
Okay.
taking only one cases, right? It will be 1 by 8.
Oh, so the
Yeah.
probability remains the same if we
Yeah.
for the minimized expression also if we draw the truth table and take it from there,
Yeah, correct.
then
Yeah.
it is equivalent. Then in
Yeah,
that case,
yeah, because the minimized expression is the ultimate circuit
Right.
that we get after the minimization, right?
Correct.
Mm.
So on that we can apply this formula. I mean,
Correct.
on that you can calculate the probability of getting it.
Yeah, correct.
Yeah.
That's right.
Yeah. Hi, Sanjay Kumar, you're like Pras, right? You are?
Yes, sir.
Okay, okay. So I like remember you're from voice, like I did not know your name. Okay. Okay, then this is another like question. Consider the switching circuit shown below, right? Taking closed as 1 and open as 0. Find the Boolean expression for the circuit when the LED does glow. So
What
you
is
have to
red and green colors?
red and green
Why
color.
do we have red color and green color in this diagram? Why do we have to?
It's like simple wire. Like don't think it's there is red and green. Simple wire is there.
Okay.
So
So, like, what will we consider for the battery source? X and Y?
no, it will be like see you can see that battery
That is the
source.
switch, no? X, Y, and Z are switches, no?
Yeah, correct. So battery source it's like kind of you can think battery is coming
So,
from
if,
that.
if we just guess
Not,
this one, X, Y are parallel. So, X plus Y whole into Z, is that it?
yeah. So
Achha, okay.
when it will be so if you can draw you can draw truth table also x y z and it will be f, right? So kind of like that. So when LED will be glow, so when suppose let's draw the truth table, right? 1 0. Right. So 0 0 0 1 0 1 0 1 0 1, right? So when all will be like 0 means like open. So when all will be like open, then it will be 0, right? Now you can see that Z is closed, but X is not open and Y is not open, so it will be 0, right? Here will also be 0, but Y and Z, you can see that this is and this is closed, so it will be 1, right?
Hmm.
Here
Uh,
will also
Excuse me, sir. One very basic question. So the F here is the bulb itself, I believe.
huh?
The
F?
F is the bulb, is it?
Yeah, F is the bulb. One LED will be glow. This means
Okay.
LED.
Okay.
LED will glow, right? Now I can see that X is 1 and Z is 1. So X, this is also closed and this is, so this will be
0.
this will be 1, right?
101 will be also 1.
And
Okay.
1 1
111 will be also 1.
X and Y, one it will be 0 1 1 0. It will be 0 because this is
Yes.
not
Z
closed.
is open.
Yeah, and this will be 1.
Short circuit.
3 by 8.
Now you can also like by common sense you can also give the answer, right? So when it will be 1, when X and Z it will be closed, like will be 1. So X Z, and another case will be when Y Z will be 1.
Hmm.
So in case will be also like you can give the answer. So it will be X Z plus, and if you solve that, if you find the SOP and if you solve, you will get the XZ plus YZ.
Same expression.
Same expression. So I'll suggest try to. Okay, up to that is clear.
Excuse me, sir, one more question. So this diagram that we have, right, the circuit diagram.
Hmm.
So there are wires, right? So
Yeah.
here I see some wires are red and some
Eh,
are green.
Uh-huh. So it's like this is a wire. Does not means like any.
Okay, okay. That color does not have any significance, is
Yeah,
it?
no. Does not any significance.
Okay.
Yeah.
That's okay. Sure. Thank
Okay. So up to that is clear. Now let's next question. Right. So the box on below, the box output app. So the box output app, one more than the half of the inputs are 0. So it will be 1 if more than the half of the inputs are 0. So it's like
Only means all three are 1. All
no,
three are 0.
more than not more than half
There are
means like
there are three inputs.
yeah,
X, Y, Z. Half is 1.5.
yeah.
Acha, okay, at least two are 0. Okay.
At least 2 are 0. That's so X, Y, Z, right? So what will be if it is 0, 0, 0, then F will be 1, right? If it is 0, let's write all the 1.
3, it will be again 3.
Okay, so
1, 0,
it will
1.
be
50%.
0, 1, 1, 0, 0, 1, 1. So when you can see that again it will be 1, right? Sorry, more than half input, so it will be 1. Here it will be also 1, but here it will be 0.
Hmm.
Here it will be 1.
Hmm.
Here it will be like
0.
0.
0, 0, 0, all 0.
Now you have to find the POS. So for POS we are taking the 0 part, right? So this will be
3, 5, 7, 8.
So 3, 5, 6, 7, right? Not
Yes.
7.
So 3, 5, 6, 7.
So I think 3, 5, 6, 7 will be the answer. Okay.
If it was SOP, it would have been 0, 1, 2, 4, right?
Yeah, correct. 0, 1, 2, 4. Correct.
What other question could be framed from this?
It can be SOP, or we can also write the what will be the minimize expression.
Okay.
Okay, so it's like kind of so like I'll say like maximum types of like all the questions like it's given in the PA and GA, like if like quiz will be also like similar kind of PA and GA. So if you're able to
But
solve all the
it
PA and GA,
requires
then
little care. I mean,
yes.
How do we find the minimal expression for this, sir?
So that's step to solve.
Okay.
And for minimization we'll be learning KMF also. So this will be in that week 5.
Sure.
So just you have to like minimize, like you have to solve all the question. This is a like kind of easy course, but you have to solving more like more problem. So if you are able to solve that Morris Meno book, that will be good. Okay, then. Okay, now we'll be asking, we'll be solving next question. So consider the given Boolean function if 3 variable f, x, y, z, summation of 1, 3, 5, 7. The given function is you have to find the independent of one variable. You have to find independence of the 3 variable and independence of the 2 variable. So you have to basically 3 variable is given summation of 1, 3, 5, 7. You have to find the function is like you have to minimize the function basically. So what 1 means 0, 0, 1, right? So and 3 means
Like if any variable is getting eliminated in simplification, is that
yeah,
it?
correct.
Achha.
So 0, 0, 1 and 3 means, so let's write here. So it will be x bar y bar z plus 3 means 0, 0, 1, right? So 0, 1, 1, sorry. So x bar y z, 5 means 1, 0, 1, right?
5
1
means 101, yes. X, Y
plus
bar Z.
x y bar z, and 7 means
It is
1, 1,
111, yeah.
X, Y, Z.
x y z. Now you can see that you can take commons y bar z, right? So you can take common from this and this, y bar z and y bar z.
Y bar Z, yeah.
Y bar z, you will get x plus x bar. Now we can take common yz, right? Yz, this and this.
Hmm.
it will be x plus x bar, right? Now you can take x
Yes,
plus x bar
Z.
is 1,
Final is Z.
y bar z plus yz. Now you can take on like then z, y plus y bar. This will be 1, so it will be z. So it you can say that it's independence of two variable.
Oh,
Correct?
one minute, sir. X bar y bar z, x bar y z, x bar z common in wait. First common is x bar z. Okay, x bar z, and the second common is.
Yz, right? So you are taking.
Sir, in the first one, what have you done? Okay.
So see these things, and you can see that these things. So you can take
One and first and third. Okay, okay.
y bar z and y bar z, and
Mm.
you can see that things and that things.
But there's another catch. Like if we do not take the right terms to simplify, our expression could get jumbled up, isn't it?
Yeah, like
That is also.
so if you take common from these two terms, so x bar, you can take from 1 and 2 also. Like if you
If you
take
take 1 and 2, you will get x bar z. And
x bar z and x bar z, so and you can also do that. Suppose you are taking common this and this, right? So it will be x bar z y plus y bar. We are taking this and this, so it will be x z, right? X z y plus y bar. Then you
either
have
way.
to take common z, so you are finally getting
Okay, you're getting z either way. Okay.
yeah. So it's
X is going. So 2 is the answer then.
so yeah. So week 3 up to that's it. If you have any doubt, you can ask. And if you have any doubt, like further, if you have any doubt, you can ask, post in the discourse, and you can ask in the chat box also. So
Okay, like again, I
Could you
mean,
write one expression, please?
okay, okay, tell me.
A plus B bar
A plus B bar
plus C bar,
plus C bar.
this whole within bracket,
Okay,
dot
dot
A plus B bar plus C
A plus B bar plus C
dot whole
dot
dot A plus B plus C bar.
A plus B plus C bar. Yeah.
We need to simplify this.
Okay. So this is the POS, right? Hello.
Mm-hmm. Mm-hmm.
So this is suppose this is the A, B, and this C, right? So let's write all the possible value. Zero, one, one, zero, zero. Right now, okay. So A plus B plus C. So this is 1, 0, 0. 1, 0, 0. You are getting 0. This is sorry. This will be 0. 0 are getting 0, 1, 1, 0, 1, 1. So 0, 1, 1. So 0, 1 and getting 0. This is will be 0, 1, 0. 0, 1, 0 are getting 0. A plus B. This is 0. Sorry, this is 0, 0, 1. 0, 0, 1 are getting 0, right? Right. So you can take SOP also after that. So this will be 1. So because SOP
No,
is
how
like,
we are making 0, 1, 1? I mean, not is 1.
because in POS we are taking as a 0 as 1 and 0 as A, right? So if we are taking SOP, so this will be, if 0 then it will be A. If it's 1, it will be bar, right? So A, if you are taking this, so A plus here this is 1, so you are taking B bar. This is 0. This is C. So now you are getting the SOP, then you can simplify easily, or you can multiply also that. After the multiplication, you also get the minimize expression.
No, so in the can we write it as A dot sorry, a bar dot bc bar dot b c bar whole to the power bar. I mean the first bracket. The first
Yes.
bracket can we write that like a bar dot bc whole to the power bar dot a bar dot b dot c bar whole to the power bar.
Okay,
Can we write like that?
okay, just I'm writing. Whatever, just can you tell A plus B bar
A
plus
bar a bar no a bar dot bc
okay. A bar
bar dot bc
A bar dot BC
whole to the power bar
whole to the power bar
dot
dot
a bar dot bc
A
a
bar
bar dot bc dot bc bar
BC B bar C
bar
bar or BC bar
bc bar
BC bar.
whole to the power no not only on c
Oh, only on C.
a bar dot b dot c bar
Okay,
whole to the power bar
whole to the power bar
dot
dot
a bar dot b bar dot c
A bar
dot b bar
dot B bar
a bar
dot
dot b bar dot c
what to the no,
bar
you cannot write.
yes
You
why is so?
cannot write because this is a SOP, right? This is a
No,
POS, right?
I was applying that the Morgan law on
DB,
individual expressions.
uh, or
Like
individual, yeah.
earlier in that
Okay,
x plus y wala thing we did it.
okay, yeah, you can also do that. So if you are getting kind of that, then you
No,
can
no,
apply.
I'm just asking whether this is allowed or not allowed.
Okay, yeah, it is allowed. So if you are applying de Bourgon's law, so I'm thinking that you are applying other things. So yeah, if you are getting a,
In that third expression there will be bar over a also.
okay, then yeah, it is applicable. It is applicable. You can apply. If you are applied de Bourgon's law, you can apply. It is applicable.
I mean within the individual brackets we can apply no,
Yeah, yeah, you can apply.
and then simplify.
Yeah, you can simplify.
So
If you are
then so third step will become a bar dot bc
a bar dot A bar B bar dot C. Yeah.
a
So
bar b a bar
if,
dot bc.
if you are simplifying this expression, then you will get this expression, right?
I don't know. I
So
mean,
so if you are simplifying this expression,
mm-hmm.
so if you apply de Morgan's law, so it will get A bar plus B bar plus C bar. Again, you're getting the same expression, right?
Just a second. I'm getting finally it is a bar c.
I think you are doing some mistakes. Can you please send the peak, or you can say, you can also
Okay, sure. I'll do that.
or share the screen also.
No, I have written in piece of paper.
Okay, just send the PDF. Sorry, send the image. That will be fine. I think
No,
you will.
when I simplified this, it became a plus c bar.
Okay, just send the. I think you are doing some.
Okay, I'll send something separately. Okay.
Yeah, yeah. Okay. So, any doubt? Okay, so let me stop the recording then. Okay, so Bimila